Welcome back. We're in section 4.6. We're going to be talking about graphing the other trigonometric functions. So if we look at the unit circle for tangent, so if we start at 0, the tangent is 0. If we look at pi over 6, our tangent is root 3 over 3. Pi over 4 is 1. Pi over 3, it is root 3. And then once we get to pi over 2, it's undefined. And then when we get to pi, it's back to 0. Now if we go backwards, if we go to negative pi and such, so negative pi over 6, it's still going to be that root 3 over 3, except it's going to be a negative now. Negative pi over 4, it's still going to be at that 1, but it's a negative 1 because we're in quadrant 4. Pi over 3, we're at negative root 3. Negative pi over 2, we're undefined again at that quadrant angle. And at negative pi, we're at 0. Now, if you notice, we have undefined at the pi over 2s, at the negative pi over 2 and the positive pi over 2. That's important to know. And also we have zeros at 0 and at pi and at negative pi. Unlike sine and cosine, tangent has a period of pi. Remember, tangent sine over cosine. So tangent has a period of pi. The vertical asymptotes are when the cosine is 0. And cosine 0 at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so forth. Now, our domain for tangent, because we have the undefineds there, it's going to go, well, actually, we'll come back to that in a moment. Our vertical asymptotes, that's what we want to find first. So our vertical asymptotes, x equals pi over 2 plus, and what we can put here is n pi. And that's some notation we're going to be practicing working with as we go through. That's going to be like a negative pi over 2. And if you add pi to that, you're at positive pi over 2. If you add pi to that, you're at 3 pi over 2. You add pi to that, you're at 5 pi over 2. That's where all the vertical asymptotes would be. Now, our key points for graphing tangent. We have our theta and our tangent of theta. Our key points, we're going to start this at negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. That'll give us actually 2 periods of tangent. Now, negative pi over 2, at the pi over 2's, it's going to be undefined. Pi over 4, it's actually going to be negative 1. At 0, the tangent of 0 is 0. Negative 1, undefined. So I'm going to go every pi over, so I have my pi over 4, my negative pi over 4, I got my pi over 2, my negative pi over 2. So since it's undefined, we have what's called an asymptote at the pi over 2's. So we have our zeros. We're at negative 1 at negative pi over 4. We're at 0 at 0, and we're at 1 at positive pi over 4. So what the graph of tangent looks like is this. It's going to kind of just go and approach those asymptotes. Now, if I put another period there, we have pi, that's our 0, and we have our 3 pi over 2. And really all we have to do for these, and it's going to have a 0 at pi, it's going to rise from left to right. So if we look at this, our domain, it's going to be all real numbers, all values for x, when x does not equal pi over 2 plus n pi. that's going to give us where all those asymptotes are. Those are all the things we can have. Now our range this time, it's all real numbers. It goes from negative infinity to positive infinity. That's what tangent looks like. It rises from left to right. Now cotangent is very similar. It also has a period of pi, but this time it's cosine over sine. So our vertical asymptotes are when sine is 0, and that's at the negative pi, the 0, the pi, the 2 pi, and so forth. So the period for this is pi. Now let's look at the key points. Theta, sine, theta. So we have our 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now, sorry, that shouldn't be it should be tangent, excuse me. Now, our undefineds are when sine is 0, and sine is 0 at 0, so that's going to be undefined. Pi over 4, the tangent of pi over 4 is 1. The tangent of pi over 2 is 0. The tangent of 3 pi over 4 is going to be a negative 1. And the tangent of pi is going to be undefined because that's when sine is 0. So when we sketch this, we have our pi over 4, our pi over 2, our 3 pi over 4, and our pi. So we have an asymptote right here at 0 because it's when it's undefined, and at pi. At 3 pi over 4, we're at negative 1. At pi over 2, we're at 0. And at pi over 4, we're at positive 1. So what cotangent is going to look like is, unlike tangent, where it rises from left to right, tangent falls from left to right. Now, once we have that, we can kind of just sketch the other ones real quick. Pi over 2, we just add pi to it. We're at 3 pi over 2. Pi, we add pi to that. We're at 2 pi. So we can just sketch our asymptotes, put our 0 at 3 pi over 2, and we're going to fall from left to right. So our domain, just like it was for tangent, it's all values of x, as long as x is not equal to pi plus, actually we could just put n pi. If n is 0, it's 0. If n is 1, it's pi. N is 2, it's 2 pi, and so forth. And our range, we're going from negative infinity to positive infinity. Now our vertical asymptotes, x equals n pi. So that would give us our negative pi, for example, 0, pi, 2 pi, 3 pi, and everything like that. That's cotangent. It falls from left to right. That's the parent function. Now, next, we're going to look at some different ways to graph these and some different things that happen with them. When we have graphing these, it's very similar to before. What we want to do for tangent, now unfortunately we have two different rules here. Tangent, you want to set what's in the parentheses, the bx minus c equal to negative pi over 2 and positive pi over 2. And that's going to give you where your asymptotes are. Once you find your asymptotes, you need your 0, your x-intercept, and that's the midpoint. It's what's in between. So just find out what's in between. And then for cotangent, set bx minus c equal to 0 and equal to pi, and do the same thing. So what you want to do is you just want to sketch your asymptotes, sketch your x-intercept, and really all you need to do is just draw your curve. If it's tangent, it rises from left to right. If it's cotangent, it falls from left to right. Now let's actually start with problem number 2 first. Y equals the cotangent of x over 3. So what we want to do is find the period. And to find the period of tangent and cotangent is pi. So what we're going to do is we're going to do pi divided by what's in front of x, which in this case is 1/3. So our period is pi times 3, which is 3 pi. And that's going to give us the distance between those asymptotes, and also the distance between those zeros. They're all going to be 3 pi apart. Now to find our asymptotes, we're going to set what's after cotangent. So we're going to set x over 3 equal to 0 and x over 3 equal to pi. Multiply both sides by 3, we get x equals 0, x equals 3 pi. So our asymptotes are going to be at 0, 3 pi, we'd have another one at 6 pi, and so forth. We'd also have at negative 3 pi. And our intercepts. Now we want to find out what's in between. So we want to find the midpoint. 0 plus 3 pi divided by 2. So that's going to be 3 pi over 2, which is 3 pi over 2, 3 halves pi. So we have an intercept at 3 pi over 2. Now, if we just keep adding adding 3 pi. So 3 pi over 2 plus 3 pi. That's 3 pi over 2 plus 6 pi over 2. That's going to be 9 pi over 2, or 9 halves pi. We'd have another one at 3 pi over 2 minus 6 pi over 2. That's our 3 pi. And that would be a negative 3 pi over 2. That's where our intercepts are. So we can graph this pretty quickly, actually. I have my asymptote at 0. So now I'm at 3 pi. And now I'm at 6 pi. I'll put another asymptote at negative 3 pi. So now my asymptotes. There's one at 0, 3 pi, 6 pi, and now in between is our intercepts. We have one at negative 3 pi over 2. We have one at positive 3 pi over 2, and we have one at 9 pi over 2. So now my amplitude is 2. That really doesn't affect us like it does for sine and cosine, because our domain is, our range is all real numbers. So it's not like we have a highest point. We're just going to keep going. So all you do, because it's cotangent, it's just going to fall from left to right, going through that x-intercept. And there's the graph of the cotangent. Let's go back to problem number 1, the tangent one. Now, the reason I skipped this one is because we do have the negative in front, and that means we have an x-axis reflection. Everything else stays the same. Our period, it's pi divided by 2. So our period is pi over 2. Everything's pi over 2 apart, the asymptotes and the intercepts. So now to find the asymptotes, set 2x equal to, now this time for tangent, negative pi over 2, 2x equals positive pi over 2. And it's going to find our intercepts algebraically. So to get rid of the 2 in front, we multiply both sides by 1/2. So we get x equals negative pi over 4, and x equals positive pi over 4. Those are our x-intercepts. Now, our asymptotes. We can keep finding more asymptotes by adding pi over 2. So if we add pi over 4 plus pi over 2, that would be pi over 4 plus 2 pi over 4. That would be 3 pi over 4. And if we do pi over 4 minus, now remember, pi over 2 is the same as 2 pi over 4. we're going to get negative pi over 4. And we already had that one. So let's make that a negative, and we'll subtract negative 2 pi over 4. That's going to be negative 3 pi over 4. And that would give us some asymptotes. Our intercepts are between the asymptotes. Now, if we have negative pi over 4 plus pi over 2, pi over 4, and divide that by 2, we get 0 over 2, which is 0. So our intercepts are actually a little bit easier. We have 0, and if we add a pi over 2, we're at pi over 2. Then we add another pi over 2, we're at 3 pi over 2. Subtract, we're at negative pi over 2, and that's where those intercepts are. They're pi over 2 apart as well. So now, I've got my negative pi over 4. I've got my positive pi over 4. There's my first set of asymptotes. And my intercept is in between. Now, normally, tangent rises from left to right. But since we're taking the x-axis reflection, because of that x-axis reflection, this one's going to fall from left to right. If I want to draw another period, my other asymptote would be at 3 pi over 4. And here in between, I have my pi over 2. So once again, it's going to fall from left to right. We have our negative pi over 2, our negative 3 pi over 4. There's our asymptote, and it falls from left to right. Those are the graphs of the negative 3 tangent 2x. It falls from left to right because of the x-axis reflection. We'll be doing more practice of this as well. In the next video, we're going to be talking about the other reciprocal functions, secant and cosecant. All right, thank you.